Hi. So this is a video for SOEN6441. This is for week 3. There are 2 videos for this week. The first video was for repositories, and then this video is going to be about coding conventions. So coding conventions is another one of these things that you should keep in mind if you want to develop code, and especially in teams. Okay, that's one of the things also that's directly related to one of the extreme programming key features that I presented earlier that somehow advocates that you use coding conventions. And as I explained before, uh, the idea was that if you have coding conventions in place, then that enforces somehow that there's some kind of quality of the code, of at least the appearance of the code that you are producing, that the code appears to be homogeneous across developers, and that the code is as much as possible readable, so as to diminish the time that it takes for different people to understand each other's code. Okay. That's the idea behind coding conventions, why you would use coding conventions. So first of all, what is coding conventions? So coding conventions is a set of prescriptive rules that will tell people how they should write code, what their code should look like, things like this. So now, first of all, this is a prescription. So as any prescription that you may get from your doctor, prescription, the nature of it is that you somehow make the decision to use it or not. Okay, so that's one of the things about coding conventions, is basically on a voluntary basis. So it requires that people will do it. It's very hard to actually enforce that coding conventions are applied. So it requires will to actually use them. That's what I'm going to come back to at the end of this video, of this lecture. It's essentially a habit that you must have out of somehow respect for the team and respect for yourself in order to produce code that is easy to work with. Okay. So what are these habits that you may have? For example, you might have file organization coding conventions. For example, how code is distributed between files or organized within each of the files. Well, that's not that much of a problem with Java, because in Java you have one class, which is one file. So you have one-to-one relationship between class and file. However, if you're using C++, you can have as many classes as you want in one file. So then that opens the question, which classes are grouped in one file? How do you make groups of classes? So in Java, we don't have that, but if you see that the coding conventions are actually somehow, some of them are related to the language or specific to the language that you are using. So if you're using a certain coding convention and then you change project, you change language, it is going to change. And talking about changing project, if you go to a different company, they might have their own coding conventions for different reasons. Okay. So you have to be able to adapt to different coding conventions. The thing is that in order to simulate that, I'm going to impose to you that certain coding conventions that you will have to use in the project, which I'm going to present at the end of this video. So using coding conventions also involves adaptation. Very often you use coding conventions which were invented by someone else, and that's not your own taste or how you do it. You have to adapt to what the team has decided, or your boss has decided, or the company. Other coding conventions can be indentation. So, for example, how many indentation characters you have every time you go in a new scope that you indent, so on. So, or if you have an if statement or an abbreviated if statement, how do you organize it? There are different styles, different ideas. You basically have to select one and then stick to that one throughout all the code. You don't want to have, for example, in one piece of code, an abbreviated if statement is written in a certain manner, and you come to another part and it's totally different. You want, anytime you have an abbreviated if statement, for example, it should look all the same, no matter who wrote it. Comments. So question is, comments is, you might say, is up to the coder to decide when to put comments or where to put comments. Where is it that you should have comments or not? Okay. So there should be some rules that will define where comments are expected. When you declare things, it's you declare a class or a data structure, or you declare some members of your class or your data structure, or you declare local variables. There's often different styles in which you're maybe declaring them. So what is the style that you are using? Or if you're declaring local variables inside of a function, do you declare all the variables at the top of the function, or do you declare some of them inside or below in the function as they are about to be used? Okay, so that's a different choice. So you see that there are some arguments to make for the different choices to make. And that's what is difficult sometimes when you want to adopt a certain coding conventions. A lot of people have their own arguments in favor of a certain coding convention. Also, very important is the naming. So when you write a program, you give names to things. Like you give names to classes or data structure. You give names to functions. You give names to variables. Now, how do you write these names? Do you prefer long names, short names? What if there are different words in a name? How do you separate the words in a name? So who does coding conventions? Of course, the person who does the code, uses the coding convention is the person who writes the code. But there's a lot of different people that may be involved in writing the code. There's the initial person that writes the code. Then there's the people that actually edits the code or changes the code written by someone else. And eventually down the line, the code goes into production. And then there's eventually going to be maintainers that are going to read this code and potentially change the code. So every of these people involved are actually involved with the coding conventions. You may also have, as you're producing the code, you may have peer reviewers or testers that are actually going to use this code or have to read the code and be somehow influenced by the nature of the coding conventions. So why should you have coding conventions? So essentially, coding conventions don't influence somehow the externally visible qualities of the software. The code can look like an absolute mess, and then you execute it, and it's wonderful. That the application is wonderful to use, but if you would look inside at the code, it's an absolute mess. Okay. Inverse can be also, the code is absolutely wonderful inside, but when you try to use the application, it's very cumbersome to use. Okay, so there's no correlation between how the code looks inside and what the application does. Okay, so the quality of how the code is organized, how it looks. It's an internal quality only. It doesn't mean that it's not important, because if you are to work with this code, if it's hard to understand because its organization is, and the way it is written and the way it looks is hard to, makes it hard to understand, then you're going to have to spend more time understanding this code. Okay, and it's going to increase the cost of actually changing this code and adding to this code. That's what you want. That's why you want to have coding conventions, because it actually decreases the cost of changing, understanding, and changing the code. So it's effectively increasing the productivity of the people that are working with this code. So you see that here I'm presenting it from the perspective of economics somehow. Okay, so reason why a company might want to use coding conventions is to decrease cost and increase productivity by making the code more readable and understandable. Okay. So how do you do that? So first of all, you have to define the conventions. There's a lot of different kinds of conventions you could imagine. If you go on the internet and you type coding, for example, Java coding conventions, inevitably you will come to, for example, the Oracle Java coding conventions, and then you'll say, oh, perfect, we're going to use this for our project. And suddenly you open this document and it's like a 300-page document that gives coding conventions in extreme details for a lot of different things. So that's the vast majority of the information in such a document would not apply to you, or you may not agree with it. So the point is that as you're forming a team, if nobody is pushing coding conventions on you, and you have to make somehow a decision. Okay. Then you have to somehow write it down as to what are the conventions, so as to make sure that everybody is aware of them and everybody is following them. If it's not written anywhere, and people will forget, and then will stop using it. Okay. Talking also about stopping using it, it's a collective habit. Okay. And it's as much as a collective habit, if you see that your teammates are using the conventions, then you will see that their code is wonderful. You might be more tempted to actually adopt their very good habits and yourself producing better looking code. Okay. The reverse is also true. If you are producing very high quality, very visibly nice code, that is easy to understand, and then suddenly in your team, some people stop doing it, and then they're creating messy code, then at some point in time, you might be like, oh, why am I doing this? And then start writing messy code yourself too. Okay. So it's a habit, but it's also a collective habit. You have to make sure that every team member is, for example, commenting on or you may have a peer review of code that is in place to point out places where the coding convention is not used. Okay. It's not something that's easily automatable, though. But for example, you could have some kind of compiler or that will check that your coding conventions are actually followed. So it has somehow to rely on peer review. It's not something that can be, for example, enforced by your compiler. However, there is in many of the IDEs that you might be using, there's some kind of pretty printer feature that will, for example, you write some code, you select your code and you type a key, then it basically formats the code in a certain predefined format. Okay. You can even, in most IDEs, you can set up what is the format that is implemented for the formatting, the rules that are applied by this feature of the IDE. Not necessarily that you want to do this, but it's possible to actually customize it for most IDEs. You can also combine that somehow with refactoring. by saying that you might deliver the software even though it looks messy. If it works, then fine. Then what you may want to do before you start the next build is to actually do an extensive peer review of the code, and then locate the places that need to be somehow cleaned up and follow the coding conventions. Okay, so you can combine that peer review of coding conventions with the refactoring operation that's happening between the builds. Because sometimes when you approach the delivery, it's possible that things will go fast and that people will somehow forget or lower their standards as they have to produce, for example. So in this case, after the build is done, then you do some peer review and people clean up where there was messy code that was introduced. Another thing that actually relates to it, the question is, one of the questions is, where do you put comments? Because comments is something that actually helps the user to understand the code. One of the goals of coding conventions is to increase the understandability of the code. Comments will increase the understandability. So you should have a certain level of or amount of comments in your code that increases the productivity by increasing the understandability of the code. Though with comments, if you put too many comments, there comes a point where the code may be drowned in comments, which then starts decreasing the understandability. So it's a fine balance. One of the things that goes into comments is, for example, the Java doc. We'll have an entire lecture on that. So Java doc is basically comments that you put in your code, that these comments can be compiled to actually generate an API documentation for your code. So part of coding conventions is often to include JavaDoc for all the classes and all the members of the classes, which we will require you to do in this course. So many of the things that I will speak from now on are essentially examples. Okay, so I'm going to go sometimes fast over this. You don't have to understand. I'm just giving you an example. You don't have to apply this in the project. I'm just giving you some examples to somehow convince you that coding conventions or quality of the code is important. Let's take these two pieces of code here. So here I have 3 lines of code. For those of you who know, this looks like this is C or C++ code. It's very hard to figure out because you see this is 3 lines of code. And then suddenly you realize, oh, there's a function here because there's parentheses and there are parameters here. And there's 4 here. But it's confusing because the 4 is at the end of a line. So you're like, if you know 4, you know there should be some parentheses here, and then you see they are here. And then you see these lines here. It's not clear which one is a new line and so on, and which line is part of the for loop or not. So you see this is a very silly job as doing clear code here. But if you compile this code, the compiler will have a very exact meaning for this code. As far as the compiler is concerned, the fact of the matter is that this code here is doing exactly the same thing as this code here. If you compile these two things, the compiler will think, wonderful, these 2 pieces of code as wonderful as the other. Okay. However, you as a human that has to read and deal with these pieces of code, as a human, you will, if you ask 1,000 humans which one is better, very likely that you will have an extremely vast majority of people that will tell you this one is a mess and this one is wonderful. Yeah. And the reality is that if all of your code is written like this, for pages and pages and pages of code, the code becomes unreadable. Okay, and it takes a long time to actually understand what it does. If you want to change it, it's a tedious operation and an error-prone operation. Okay. So code readability, it's a very important code quality. As I said before, if you compile these two things here, the compiler will generate essentially the same functionality. Okay? So when you use the code, you execute the code, there's no difference. But when you actually look at the code as a human, there is a lot of difference. And this one will make your life much easier. You'll be much more efficient and productive in your coding if you deal with code like this than if you deal with code like this. So what are the basic rules that will increase readability and understandability? So you should use a clear and consistent layout. So by layout, what I mean is how the code is laid down across lines. Okay. For example, here you see that this is a function. Clearly, this is a function header. And then you see that this is the code block for this function. And you see, for example, here the for loop is totally here. And then you clearly see here by the indentation that only this line is part of this for loop and that these here are not part of the for loop. So this is the indentation that tells you that. Okay. You don't need to have indentation. The compiler doesn't care about indentation, but you as a human, you might be misled by wrong indentation or by lack of indentation. There's also the names. The names that you use to name your variables can be very important. So for example, here, the parameters of this function. So it receives a variable named m and a variable named g. This does not tell you anything. There's a variable tm, variable t, variable I. This does not tell you anything about what this piece of code is doing. However, here you're using marks, and grade, and total marks, and so on. So this is much more, makes the code much more easy to understand. So the names that you give to the variables or every identifier that you name in your program is very important. What name exactly? What names do you use to actually name these things? Then you have the comments. As I mentioned before, of course, if you have, sometimes comments are necessary to actually understand the code. Just reading the code itself might be might be cryptic. If you have some comments here and there, might help the reader or another programmer to understand the code much easily. Now, I already mentioned, give an example about code layout. So code layout, for example, includes a nesting level. If you have a for loop or while loop or an if statement, imbricated if statement, then you might want to indent them in a specific manner. Use this example here. So here you have two different styles of creating indentation or layout of an if statement. So here you have an if else here, and you see that here the code block for the then part of the if is very clearly indented here, and the curly brackets are the beginning and the end of the block on an empty line, clearly showing that this is the beginning and the end of the block. Now, this is creating more lines compared to this other way of doing here, where if you have a code block, then the curly bracket is at the end here, and then the closing bracket is at the beginning here. So this actually creates code that is more compact, whereas this one is creating code that is more elongated. Then people say, well, it's better to have more compact code because then the code is, you are more likely to see all the code in one screen. Okay. Of course, scrolling to code, the more you have to scroll, the more it's likely that it's going to be confusing. So if you have more compact code, people might say it's better. However, this one is more visible. It's more like air in the code. Okay. whereas this one is more compact. But yeah, so there's not to say that this one is absolutely better and that one is absolutely wrong. There's advantages to both of them. You just have to make a choice. The most important thing as a team, you make a choice and then you adopt this choice as the entire team. That you don't open the file of person X, it looks like something, and you open the files written by some person Y, and then it looks like something very different. When you open different files from a team, all files should look the same. That's what I'm saying. Indentation can also lead to problems. For example, here you have a while loop, and then you have two lines of code here that are indented at the same level. Now, if you know the notion of a programming language of this kind, which is probably, for example, C++, then you would know that if you want to have these two lines here in the while loop, then you should have curly brackets at the beginning and the end, enclosing these two lines. If you don't, then only the first statement after the while is part of the loop. So you see that here, misuse of the indentation can actually lead people or mislead people in misunderstanding the code. Okay. So indentation is not only just for the visual enjoyment, it may actually misindentation or misleading indentation can actually lead to problems in understanding or even creating bugs. This we already covered. Then there's a notion, as I mentioned here, there's a notion of blank lines. So here it's not totally blank lines, but you have, every of the beginning and end of a code block is somehow in, you see, you have more somehow air in the code. The code is more aerated. So these blank lines are, putting some kind of pause in the code and attracts your attention as to there's different parts in this code. Whereas if you don't have any blank lines, it's more difficult to see where are the different parts. Okay. So sometimes using blank lines is a way to make your code to attract the attention to the reader as to where are the different parts. For example, you may have different methods in a class, and you may want to put blank line between each of them so as to make sure when you scroll that you see this is a method, this is another, because there's a blank line between all of them. Of course, then if you start putting blank lines inside of the code of each of the methods, then it misleads the reader in thinking that this is a different method. So you have to be consistent in your usage of every of these conventions. Now, what about naming conventions? So this was essentially about the layout of the code. How does it look when you actually look at the code? You're reading the code or browsing through the code. Another thing is naming conventions. So typically in a program, you give names to things, such as a class or a data structure, a constant, a local variable, member function. If you have free functions like in C++, all of this, you give names to them. So it's, as I said before, it's very important that you give meaningful names, but even then there are some other choices that you may want to make that are going to lead the code to be more understandable. So there's a lot of different conventions that you will find. I will actually enforce that you use some convention that I have written myself. Maybe you will not like this convention. The exercise is to, as I said before, if you find a job and you go to work for a company, extremely likely that they will have their own convention that you will not like. This is about adaptation. Okay, that's why if you don't like my convention, that's part of life. Okay, you will come to somehow, as you will be using it, you will come to realize that it has its own advantages. Some of the conventions here I'm just giving you examples. Okay, so some of the conventions, some people say that the more, for example, you name, let's say a variable. If you name a variable as the counter of a for loop, then this variable has a very restricted scope. It is used in a very restricted number of lines of code. So then you can use a very small identifier or name to name this variable. The more a variable is likely to be present in a larger amount of code, the more it is desirable to have a longer name to describe it, because it needs to, it possibly requires to be used in different contexts, and it needs to describe more precisely what it is. Okay. So essentially, the more a certain name is used in a larger scope, the more it should have a more descriptive name. And the more it's used in a smaller scope, the more it's not necessary for it to have a descriptive name. Of course, there is a limit to the length of a variable. You don't want to have variables that are composed of 20, 30 characters. Okay? It just makes your lines longer. Every time you use this variable in a statement, you use this long variable name, it makes it more likely that this statement will be longer, will span over multiple lines. That makes your code less readable. So there's a compromise to be made if you consider the length, the necessary length of a variable name. Very often people will, you've seen this all over the place, if you name a constant, then you name it in all capital letters. If you have several words in this name, then you separate them by underscore. This is something you see all over the place. You don't have to do that, but somehow everybody's doing it. And then everybody, when they see capital letters, they know it's a constant. But more specifically, very often a constant global variable. Another thing that most people have is if you name a class or a data structure, it starts with a capital letter. Another thing that is the question is if a variable name, if a name has several words in the name, then the question becomes, what do you do to separate every word? Some people would put underscores to separate every word, but that has a tendency to create one more character for every word you have, thus making the identifier longer. Some people use what is called camel case naming, which is basically here you have three words. First one starts with capital, and then the second one a capital, and the third one a capital to separate somehow visually the different words. The camel case is very common. Here I'm going to go very quickly over this. So in Brown University, if you search on the internet on Google, you'll find a whole lot of different naming conventions that they use in their different courses. They've done this for years. That's why it has become somehow a good example to show in a course. I'm not saying here that you want to use that. Here I'm just showing that there's a lot of sometimes different sometimes it's not only about how the code looks that you adapt a convention. Best example probably is this, the first one here. So when, for example, in the code, if you want to use or to name a file, to define the name of a file in the code, to hard code a file name in the code, then you'd much better to use small letters for the entire file name. Why? Because some operating systems will be case sensitive. So if you want your code to be portable, then you should not use cases at all to make sure that it works, whether or not the operating system you are using is case sensitive or not. Okay, so you say, name a file, only small letters. That solves the problem. So you see here that does not have to do with the appearance or readability of the code. There is a practical reason for which you want to use this coding convention, which is basically portability of the code. So sometimes coding conventions, it's not only about the looks of your code or how understandable, it's about also practical considerations. So that's what I wanted to show here. I'm going to let you read the other ones here, and you'll see that these are each have to do with practical considerations. These are some others that are very often seen. So for example, if you have method names, then you use camel case, but that starts with a small letter. Some people would say, again, as I said before, you may use underscores for attribute names to separate every word in the name of an attribute. If you have constants, then you may want to use capital letters, all capital letters. If you define a local variable inside a function, then you may want to not use underscores. Okay, so that's just examples of what people adopt as coding conventions. The thing is that you have to choose your own coding conventions or adopt them as a team if the company you work for has their own conventions. Some others, which looks much more like what I'm going to be telling you to use, is these two here. So for example, here what it says is that if you define the names for the variables or the parameters of a constructor, then you name them with new. And then at the same time, you name your data members starting with D underscore. So the parameters new underscore and the data members D underscore. So that, for example, because often you have this problem that if you receive hours and then you will set hours using the constructor, then you can't say hours is equal to hours. That solves the problem if you name these all new and these, the data members, all D. So D hours is equal to new hours. You see here, that's a practical consideration. Not only that, also, if you're in a method that is not a constructor, and then you see a name starts with D underscore, then you know this is a data member. Sometimes it's not clear when you read code which variables are data members or not. So if they all start with D underscores, that tell you what kind of variable that is, which is useful information to more quickly understand the code. And that leads me to say, because here what I'm saying is that the notation that you use to name your variables tell you what kind of variable they are. It's exactly what's called a Hungarian notation, which is still part of Microsoft, even though this has been done decades ago. It's still part of MFC, for example, in many places. So it's called Hungarian notation because it was invented by Charles Simoni, which was working at this point for Microsoft. And he is his nationality is he's a Hungarian. So that's why it was called the Hungarian notation. Other reason why it was named the Hungarian notation, it has a tendency to create very long cryptic names for your variables. People were not able to read them aloud, so they were saying, oh, maybe it's Hungarian because they could not pronounce them. So that's a little bit humoristic way to describe why people were saying this is Hungarian notation. So what it does, a Hungarian notation, is that in the variable name, it somehow advocates that you put information as to what is the type of this variable. For those of you who have used C++ or C, you would realize that the type of a variable is often very important in order to figure out how you would use this variable name. Okay, that's why Charles Simoni decided that he's going to put information about the type of the variables inside of the variable names. So that leads you to have variable names such as, for example, LPSZ message. So if you know this Hungarian notation, then you would know that this is a variable named message, That's the name of the variable. And these characters here describe what's the type of this variable. So this variable is a long pointer to a string terminated by 0, okay, LPSZ. And that tells you a lot of things about this variable just by reading their name. Okay. Now, of course, that has a tendency to make your code more cryptic when you look at it. But if you are used to this notation, then it tells you a lot of information. It has also some disadvantages. For example, what if somebody wants to change the type of the variable, then they would have to change the name of the variable. Or sometimes when you use a certain C++ compiler, a certain type might be translated into some kind of operational details. For example, the size that is used to store this variable would be a certain of a certain nature as you compile it with a certain compiler, and then you put it on another compiler, it has a different behavior. So you might think it's going to tell you exactly how this variable should be used or how it would behave. It might be confusing if you port this code to another compiler. Okay, so all this to say, there are advantages, there's disadvantages. Now, what about commenting conventions? So of course you want to put comments. Why do you want to put comments? Because you want to inform your fellow programmers about what's the nature of this code, of the code that you are writing. If you think something is not so easy to understand in your code, you put some lines of comments to actually describe what it is so as to hopefully make it easier to understand. Now, you might think then that the more you put comments, the better it is because that increases the understandability. Not so, because if suddenly you put so many comments in your code that there's actually more comments than there is code, then it becomes hard to see where the code is. The code becomes drowned in comments. So of course, there's a limit to this, to the value of comments. If you put too many comments, it starts having a detrimental effect. So one of the rules that you can think of about whether you want to put comments or not, the rule is comments should not provide information that can be easily inferred from the code. So essentially what this rule says is that if the code is not, if the code is made so that it's easy to understand, then you should not put code. On the other side, if it's not so easy to understand, that you should add some code, some comments. So let's see some examples here. So notoriously, sometimes you see some people that are keen to put comments, would put comments on code like this. Let's say counter plus plus increment counter. Well, this is absolutely useless comment because it's very, very obvious what this is doing. So this is basically adding noise to your code. It's not useful. If it's not useful, you don't put it. Okay. Same thing as here. So anybody that knows a for loop would know that this is what this for loop is doing. The other side meaning of this rule that I stated on the previous slide is if you feel that you have to add a line of code to this, a line of comment to describe some code, then maybe you should actually change the code so that it's readable so that you don't need the comment. That's another interesting side effect of this rule. If you feel that you have to explain the code using comments, maybe what you should really do is to actually make the code more easy to understand. Okay. For example, instead of having these that require explanation, maybe you can have this, which is much more clear. So then the question becomes, where do you put comments? Okay. So But that may have to do also with what is the nature of the language. For example, some might say, well, you should put comments at the beginning of every file to describe what is in this file. What is the purpose of what the code is in this file? Now, that's not that much useful or does not make much sense for Java in the case where, which is the case where uh, a file contains a class. So evidently, if you open a file, then there is one and only one class in this file. So it's kind of not very useful to say, what is the content of this file? So that's another example saying that sometimes coding conventions, including commenting conventions, are dependent on the language that you are using. So yes, so using C++, there could be many classes in this file. Then it becomes important to describe what is the purpose of this file, of everything you will find in this file. What is the common elements or purpose of each of the classes that are in this file, for example. Some will say before every class declaration, you should have a block of comment that describes what is this class, what is this used for, and so on, so on and so forth. And then some people say before every method, you should have a block of comment that describes what is this method, what it's doing, what are its parameters, what it returns, and so on. So especially for these two here, that's what we're gonna enforce that you do in the project. For every class that you have, for every method that you have in every class, you will, we will ask you that you provide Javadoc for every of the classes and every of the methods. So that's the coding or commenting convention that we will enforce in the project. Another commenting convention might be saying, if you have a long method that is doing something that is quite complex, maybe what you want to do is every somehow step of the algorithm that it implements, that you put one line of code that describes what this next step is or next block is doing. Okay. If somebody needs to understand this entire procedure, that the person is told, here we're going to do this, here we're going to do this. So the steps involved in the processing are described using comments. So normally you do that only when a method has a certain length and a certain complexity, and it's hard to understand what are the different steps or differentiate what are the different steps involved. So as a summary, so you have layout convention, naming conventions, and commenting conventions. All of these are aiming at increasing the code readability and the code understandability. Eventually, these will all somehow increase your productivity so that you produce more code in a certain given time, and you'll spend less time to understand the code that was already there, thus saving some time and saving some money. So again, it is about productivity and somehow increasing your profit margin as you are developing software. That's why it is important. So one of the things is that the only thing that it actually requires is discipline. Nothing will force you to actually adopt the coding conventions. If you know, for example, if you write code and the code is wrong and it doesn't compile, you don't have a choice. You have to fix it. However, you could write a piece of code that does not follow the coding conventions. It compiles. You can deliver this code. The client is happy. Nobody sees it. But if you have to deal with this ugly code for a long time, it may, in the long run, actually cost you more money to deal with this badly looking piece of code, badly understandable piece of code. Essentially, it requires discipline to keep on doing it and convince you that this is better for the long run. Even though it's more trouble now, it is going to be better in the long run if we produce nicely looking code that is easy to understand. So what is it that you're going to have to do in the project? So you're going to have to use the following conventions. It's quite simple, but what we require is that you do it everywhere. Okay, so this is going to be graded. Anytime we see, for example, in the marking, when you deliver the software, the marker is going to look for whether you're not you're following this convention. There's going to be marks associated with that. Any point in time the marker sees that you're not using it at a specific place, you lose marks right away. Okay. So it's not, for example, you receive 50% of the marks if you use it only 50% of the times. If the marker sees that one place you don't see it, then you may lose 1 mark, and there might be 5 marks for the entire thing. So if the marker sees 5 different places in your entire code where you did not use it, then you will receive 0. Okay, so it's going to be as drastic as this, so that as to force you that you really take care of doing it everywhere. The thing is that if you do it somewhere and it's somewhere else you don't do it, it loses in its entire value. It has value only if it's used everywhere. And you take the habit of doing it and actually checking each other and forcing each other to tell each other you didn't use the convention here, and so on and so forth, and maybe do some code reviews, and then support each other in this habit. So yes, so these are very simple, but we're going to be very drastic in the marking for it. It's not going to be a lot of marks associated with that, but every time you don't use it, you're going to lose some marks. So you should use a camel case for class names. The class name should start with capital letter. The data member names should start with D underscore. The parameters names should start with P underscore. And the local variable names for variables inside of functions should start with L underscore. There should be consistent layout. So I suggest that you use an IDE auto formatter and that you use it consistently. Every time somebody codes, then they just basically apply the auto formatting. For comments, there should be java.comments for every class and every method of every class. Long methods should be documented with comments for each procedural steps, as I just mentioned a few minutes ago. And there should be no commented out code. Okay. Anytime we see code that is commented out, we lose marks. The structure, because so the structure of how the project is organized is also some kind of a coding convention. There should be one folder for every module in the high-level design. So for example, we'll see a model view controller architecture later in the course. If you adopt this architecture, then you should have a folder model, a folder view, and a folder controller. So if you had, for your different modules, you should have one folder for each module. Then when you do your tests, then the tests should be separate from the code. So there should be a folder for your code and a folder for your tests. And then there's a folder structure for your code. The folder for the tests should have exactly the same structure. If there is, let's say, MVC in your code folder, there should be a test folder that has MVC, or model view controller. Okay. And then eventually for the test also, there should be a one-to-one relationship. Let's say you have one class in your code, then the tests that are testing this class should be in one class in your tests. Okay. We will see tests later, but the structure of the testing folder should mirror somehow the structure of your code. That's another convention that we will check. We impose it, that we will check at the delivery of your builds. So that's it about that. Thank you.